All right, so I guess we can start. Hi everyone, my name is Simonas, and today I'll be giving you an introduction to data engineering. And I guess before we can start, I should mention that if you have any questions during the session, feel free to, shoot them directly or just ask them in the meeting chat. I'll try to follow the chat, and if I'll see any questions posted there, I'll just answer. And you can interrupt me at any time. So yeah, I've been working in data-related roles for I think almost 8 years now. I started my career after graduation by doing some data analytics. Later on, I kind of requalified or changed my career path more to software development. And then I came back to data analytics again, and now I'm focused more on data engineering. And if you'd like to connect or ask any questions after the session, you'll see the link to my LinkedIn profile in these slides. And yeah, you can just reach me out and ask any questions you have. So the focus areas of my team in Infia are ensuring data quality, meaning that we are implementing different practices and procedures so we could deliver the best data to our customers. So my team is responsible for monitoring, for evaluating data quality and suggesting some areas for improvement, like figuring out new procedures or using new technologies to have the best data delivered to our customers as possible. Another focus area is doing the data analytics of Infia. So we are supporting business with data reports for better data-driven decisions. So we are touching all the business areas in Infia, starting with finance, data collection, employee statistics, like workflow tracking, and so on. So we are building both data pipelines and doing analytics as well. And finally, we are working also on data governance. So we try to start some data governance practices in Infia to improve the level of data analytics that we deliver, and try to do our best in evaluating the data assets we have, and yeah, working with other teams on figuring out how can we improve our data we have in Infia. And maybe just a short introduction about the company as well. So in Infia, we are collecting ticket prices from airline websites. We are aggregating that data, cleaning it up, and selling it to other airlines. And I think a few weeks ago we had a session in Women Go Tech where Infia was introducing, its business. We had some colleagues that were talking about the work they do and their everyday, life at Infia. So feel free to find the recording and rewatch if you haven't seen it before. So before I start talking about data engineering, I think what's important to mention is what are the differences between data analyst, data engineer, and data scientist. Because this is a question I often get from both, colleagues and mentees who are not, familiar with the data field. So yeah, I guess in short, these are the three main roles in data technologies. The first one is data analyst. So what does data analyst do? Data analyst analyzes all different kinds of data, usually numeric data, and uses it to help companies to kind of make better decisions, or as we say, to make data-driven decisions, where business owners are kind of running the company based on the data and not, some abstract gut feelings. So the responsibilities of data analysts include pre-processing and data gathering, which means investigating what kind of data the analyst could use, trying to understand what data that is, where did it come from, how can it be used, and maybe doing some sketches on how to gather the data, whether it's manual data gathering, let's say by downloading some data and analyzing it or transforming it in Excel, or doing some sketches on how can that data digestion and reporting can be automated. But of course, the main job of data analyst is to represent the data by using different kind of reporting tools. Excel is also, one of these reporting tools, and that can be used for making some graphs. And the job of data analyst is to, find the business problems, or in some cases, the data analyst can get the business problems for the other colleagues. So other colleagues could approach the data analyst and ask for some insights on the data. And then the data analyst would provide some data visualizations that kind of helps to solve or understand those business problems. In some cases, data analysts are doing also statistical analysis by trying to evaluate the data he or she has by using statistical methods, in some cases by calculating simple, averages, standard deviations, or maybe some doing more, more sophisticated analysis like hypothesis testing. Also, a data analyst is responsible for data interpretation as well, because all the data can be interpreted in many different ways. So usually the job of data analyst is try to find, the right way to interpret the data. And also, as I mentioned, the data analyst can be responsible for data acquisition and maintenance, meaning that once the data is acquired, let's say it's loaded to databases, the data analyst could also analyze, the whole process and to see if the data is correct or not. But in some other companies, that data acquisition and maintenance could be also covered by data engineer. So next we have data engineer. So data engineer mainly is involved in extracting, transforming, and loading the data to, taking data from source, doing some transformations, and sending the data to some destination. Or it can be, or let's say, as I sometimes like to say, in simple terms, moving data from point A to point B. So data engineers develop, construct, test, and maintain the whole architecture for data pipelines, meaning that they are responsible for, let's say, setting up databases, like creating database, assigning access to the database, trying to determine like which data storing technologies should be used, whether it's databases or some raw CSV files. Also, data engineers can also be responsible for deploying machine learning models, meaning that data scientist could create some machine learning models, and it could be that the data engineer is responsible for deploying those models from like test or development environment to production environment. But I guess usually the main responsibility of data engineers is building data pipelines for different kind of ETL operations. And in this case, ETL means extracting, transforming, and loading the data. And I'll talk about ETL in more details a bit later. Also, data engineer could be responsible for ensuring data accuracy, meaning that the data engineer could create some tests or some monitoring jobs that would check if the data that we digested to our system is accurate, if there are any anomalies in the data, if the data was extracted and loaded in time, and whether there are some delays or not. And finally, we have a data scientist. So data scientist, as I like to call that role, like a advanced data analyst. Usually data scientists work with more data, with more complex data. They usually cannot operate the data in Excel files, since the data volumes are too much for Excel to handle. What they are focused on is either analyzing the raw data from many different systems, many different files, many different databases, and creating models that can be used by the company, whether it's for like analyzing internal data, or in some cases building products from the data they have. As well as data analyst, data scientists also do data analytics. They also are responsible for doing optimizations on the data processing. So it could be that data scientist gets some data from data engineer, but they need to have more data, and let's say the data engineer hits some limitations on moving the data from point A to point B, and in that case data scientist can also help with moving that data in an efficient way. They also usually experts in machine learning. So they know many different machine learning techniques, and they know how to work with different kinds of data. They also are doing some ad hoc analysis, meaning that they could take the data that's been loaded to data warehouse and do some analysis on, let's say, historical data, like analyzing, like applying some machine learning models on data coming from last 10 years. And usually the other ones who kind of work as intermediaries between the business owners, like or in other words, stakeholders, and the final customer. So they could be developing some machine learning models that would process the data and give that data to the customers so they could use that for their own purpose. So yeah, that's the short overview of those three different roles. I guess in general, what's important is that in order to have a successful data teams or be a successful data company, it's really important to have different roles in the company. So for example, in my team, we have one data analyst and two data engineers. We don't have any data scientists, but so yeah, those data engineers are preparing data for data analysts to use, and then all of us can specialize in the area where we are the most competent. So if we have data engineers who are preparing data for data analysts, it means that the data analyst can focus on creating reports, dashboards, looking for some insights from the data we have, and then the data analyst does not need to think about how to get the data or where to get it, or how to get it, every day or every hour. For such tasks, we have data engineers who are building those pipelines. So data engineering, in general, is a practice of designing and building systems for different kind of data workloads, for collecting data, for storing data, and in some cases, analyzing the data as well. And we can imagine the data engineer as a software developer, kind of person who writes code, who creates databases, writes code in databases, or some programming languages as well. But in this case, that software developer is specializing in data, or more commonly, data pipelines specifically. And what skills are the most common for data engineers? So one of these skills is data warehousing, which also I'll talk a bit later about. ETL, as I mentioned before, it's really important for a good data engineer to have both programming language knowledge. So in my case, I use Python for like working with APIs or doing some custom scripts or custom jobs for getting the data from different kind of sources. And also it's important to know SQL as well. Since most of the data is stored in the databases, so it's very, very important to know how to select the data from the SQL databases, how to do transformations, and how to maybe move that data from one table to another or from one database to another. Also, for data engineers, it's important to have an experience or understanding on how to design data systems, meaning that if I get a request to get some new data, let's say from web or API, to build a pipeline to move that data from API to our databases, then I need to know how the whole architecture would look like. How would I get the data? What kind of transformations I would expect to do on the data, and how the final destination of that data should look like. Like what tables should be created, what columns do I need, what data types each column should have. And we'll see how that looks like in practice later when we get to the hands-on exercise. Also, some data engineers need to have a knowledge on machine learning concepts, especially those who work with data scientists, because data engineer needs to know how the production machine learning pipeline works, how to deploy it, and so on. And yeah, scripting is also a part of data engineer job. Of course, all these skills really depends on the company and on the specific role that it is there in the company. Also, for data engineers, it's important to know how to create some basic reports, because of course we have data analysts who are responsible for creating reports, but in some cases data engineer really needs to, or maybe in all cases, data engineer really needs to understand the data they're working on. So we need to know at least some basic like reporting tools or techniques to visualize the data we work with, and to have a better understanding on how the data looks like, which is really useful when we are building and designing data pipelines. Also, data engineers in some cases need to have some cloud knowledge. So nowadays, a lot of companies are using AWS, Google Cloud, Microsoft Azure, or some other cloud providers to run their data pipelines, to run their models, to store the data in the cloud. And also, it's important to know different kind of techniques for working with data, whether it's batch processing or streaming data processing. And guess what's the most important thing for me is that data engineering really has application in every industry. Like I can't imagine a company where that company wouldn't see, benefits from having data engineers, since it's, it's really important to have data engineers if we want to understand our business, if we want to know, if we want to have like good insights of the business we are in, and especially if we want to have good data-driven decisions. So I mentioned data warehousing as one of the skills for data engineer. So data warehousing is a process or like a framework of collecting data from different kind of data sources, doing some transformations, and storing that to the data warehouse, which later on can be used for providing business insights. And the data warehouse can be used for many different purposes, like we can build dashboards on the data we have in the data warehouse. We can do some custom reporting, maybe just connecting our Excel file to the data warehouse and doing some data analysis in the Excel. Or maybe just writing some simple SQL queries to better understand the business we have, or to understand some business challenges. So the main benefits of data warehouse is informed decision making. So since all of the data is consolidated from many different sources and it's stored in the centralized location, then when it comes to answering some business questions, it's really helpful to have all this data in one place. Because in some companies, it could be that, let's say we have a sales team and we have a development team and marketing team as well. And these three teams could, have different kinds of data they work with. In some cases, it could be that they work with the same data. For example, let's say number of orders our customers create. And it could be that since they're using different source for that information, they have different conclusions from working with that data. And if all of that data would be loaded in data warehouse and kind of centralized, then all our colleagues would be working on the same data set and probably will have the same conclusions by analyzing the same data. Also, data warehouse is very powerful when it comes to historical data analysis, since most of the warehouses are designed so they could store many different days and years of the information. So, for example, in our team, we keep records of our customers' orders for, I think, almost like past 10 years now. So when we are building this data warehouse, we are thinking of how to create those tables and databases so we could store a lot of information in there. Also, data warehouses kind of provides data quality, consistency, and accuracy, meaning that data we load there is of good quality, since we are checking the quality of data during the ETL process. We are checking if we are loading that data consistently, meaning that if I expect customers' orders to come in every day, then I would apply some checks where every day I would run some data tests, and I would see if there are any gaps in the dates. And if I find out that, let's say, 2 days ago we did not load any data for the customer's orders, then that something went wrong, and as a data engineer, I need to investigate why we are missing this data. And another benefit of data warehousing is separation of analytical and operation workloads. What that means is, let's say we have a system, some kind of a product that our customers use, and that product consists of, let's say that product is some kind of software that is developed, and as a data analyst, I want to analyze the data that we generate from that product. Let's say I want to check how many users are coming to my website, how many orders they create, how many data they buy from us. So one way would be to kind of use that product databases directly. And if I were to run some kind of difficult query, it could be that I would impact the performance of the product, so much that the product might slow down or even stop working. So where the data warehouse helps in this case, so if I need to have some product statistics, I would check with the developers what is the most convenient time for me to get that data. And let's say I get an answer that at 1 o'clock at night, we don't have many users using our product. So I would create a data pipeline where every day at 1 o'clock at night, I would copy the data of that, product databases. I would do some transformations, and I would load the data to the data warehouse. And then the data analyst can see exactly the same data in the data warehouse, and they are not affecting our, operational databases at all. So we are kind of minimizing the risk of impacting our products, by doing the data analytics. So how does the data come to the data warehouse? Usually by data pipelines. And the data pipeline is a method in which we get the raw data. We ingest it from different kind of data sources. For example, our Amazon account where we are, let's say, selling some products, or another data source could be our finance database, like I don't know, I think in some cases Salesforce is used for that, or that could be some Excel files that our colleagues provide manually. So data pipeline can kind of plug into any data source, extract the data, do some transformations, and send that data to any kind of destination. And I guess for the purpose of this presentation, let's assume that we always are getting data from some APIs or some like product databases, and we are sending that data to our data warehouse. So the data in data warehouse usually comes from many different data pipelines. In our company, we have, I don't know, I would say medium-sized data warehouse, and we have around 80 or 90 data pipelines that every day sends the data to our data warehouse. And what are the steps of data pipeline? So first of all, we need to investigate and understand the data source that we'll be working with. So if that would be the finance database, then I need to know how to connect to that database, in which information, in which tables the information is located, where can I find like general ledger entries, where can I find information about, let's say, products that we sell, where can I find information on invoices we send to our customers. So I would kind of document that data and prepare a plan on how am I going to like design the data pipeline. Then I would do the data ingestion. So I would write SQL code if the source is the database, or create a Python application that would get the data from that finance data source. Then I would apply some transformations, maybe rename some columns. And finally, I would store that data to a destination. So in this case, data warehouse. Then I would want that pipeline to run every day. So I would need to schedule it. Usually we are using different kind of scheduling tools for this purpose. In some cases, we can even use like Windows. I think there's a task scheduler where you can create some kind of automation that would run every day, and maybe that automation could run my script. And finally, I would create some kind of monitoring to check if my pipeline is running successfully. And in the data pipeline, there could be many different data transformations. So we could filter out some data. So maybe let's say we have many different companies in different locations of the world, and let's say our goal is to analyze only data from our European companies. So then when I would load the finance data, I would filter out non-European countries. In some cases, we might apply some masking, like due to GDPR, where we need to anonymize our data. For example, maybe I am investigating or analyze. I would want to analyze customer orders, but due to data privacy reasons, I can't really use customer emails for that. So in the data pipeline, we would apply some data masking for customer emails. And maybe in some cases, I would need to do aggregations. So let's say the data I get is coming in like every time our customer creates an order. But for analytical purposes, for me, it's really enough to get the customer orders aggregated per day. So in that case, I would create some aggregations as well. And in some cases, we might need to change the data types of the data we get. And as I mentioned before, there are different kinds of data pipelines. So usually they are categorized in two types. One is data coming in batches or in streams. So a batch means some like large amount of data being processed at the same time. So that could be 100 rows, that could be 1,000 rows, that could be 1,000,000 rows. So if I were to schedule my data pipeline that would run every day, that would probably mean that I'm processing my data in batches. So when the day ends, I'm loading all the data that we produced during yesterday. And then I would do some transformations and load that to the data warehouse. But in some cases, having data updated once a day is not enough. And maybe we want to have some real-time or near real-time dashboards, then I would create a stream processing pipeline, meaning that I would write some script that is running all the time, and that script would check if we have a new data coming in. And if, let's say, customer creates an order, then I would get that information to my streaming data pipeline, and I would process that data instantly. And then maybe our data analyst would create some live reports that are showing the information in the real time. So yeah, that's a short introduction on the data engineering, data pipelines, and the data warehousing. And I guess it would be more interesting if we try to create a small data pipeline. And do you have any questions up to this point? All right. If not, then let's try to build our first data pipeline. And when designing this exercise, I tried to cover all of the points that I talked, before. So what we will be doing is we'll try to load some data from API that provides basketball statistics data. I will transform that data, send that to our data warehouse, and then in the end, maybe just if we have time, quickly create a small dashboard on the data from the warehouse. And before the session, you got some links where you could install databases, Python, and so on that I'll be using here. So I will not be showing how to install these programs, but if you're interested and if you didn't manage to install it before, you can also ping me on LinkedIn after the session, and maybe I can help you with setting that up. All right, so in order to get basketball statistics data, I really like this free API where we have statistics for NBA games, I think from up to like 90, 80s or something like that. So yeah, we really have a lot of data in here, and I'm not sure if you have worked with APIs before, but like in short, what APIs are, they are a way to get some data by having a link, by doing a GET request. GET means that I need to get information from this link. And then we have different kinds of parameters that we could use for our API. So for example, we could provide a season for which we want to get the statistics, or we can provide some specific dates from which we need to get the statistics. And this in this web page, there is a short documentation on how to use the API, but I won't go through the specifics, but I'll show a quick example on how can we use the API. So for using the API, we have different kinds of tools. One of the most popular one is Postman. So this is a free tool where we can do tests on the APIs, and just to try it out and see the results we get. So in this case, okay, let me just clear this one. I'll copy the API address that I'll be using here. And if I just click send, what it does, it sends a GET request, this API, and retrieves some data. And data is returned in JSON format. That's a pretty common format that APIs return. And one of the tasks of data engineers is to get the data in JSON format, transform it, and load that to some kind of format that our business users can easily understand, meaning that some simple data tables could be a destination of this data. And this is the kind of prettified response of the JSON. There are also different kind of JSON viewers that we can use. This is, I guess, my favorite one. So what I'll do, I'll just copy the whole response and I'll view it on the JSON viewer. And now we can see how the data in JSON looks like. So it's kind of nested data with different levels or different layers. So we have some metadata information, meaning that there are total pages, almost, I think, 62,000. Each page has 25 lines of statistics, like 25 entries. And then we have the actual data that we got from the API. And in here, we can see that we have like 25 entries of the data. And if we check the first one, we can see that probably this is one instance of statistics of some player doing some specific game. We can see that that player got 1 assist, some rebounds, I don't know, maybe some points as well. So this is the data that we'll be working with. We'll try to transform it, and we'll try to load that to the data warehouse. And I'll go quickly through the code in here. So this is a small example in Python where I've loaded some data and sent that to the database. Usually when I want to start those simple exercises, and if I have some task that's not, let's say, not very complex, in some cases, I'm using ChatGPT to write some examples of code. So in this case, let's say I want I want Python code that would query API and load that data to database. And it kind of generates some basic example of loading the data with comments and also instructions on how to use it. So let's simplify this one. Let's use only querying the API. So you can see that the code used the request library. We have some URL that we'll be using, and we are querying the API. We're checking if our query was successful, and if it was successful, then we are saving kind of the data. And this is mainly the same thing that I did in my code as well. So let's try to create a new file in here. Let's extract on hand and let's copy this code. So what we need now is we need to change the URL of the API. And for this API, our URL is this one. We are doing the get request, and let's assume that our request will always be successful. So I'll remove all those checks and I'll simply load the data and I'll see what is the result of this API. So in order to run this code, we can use this one, run Python file, or we can just click F5 on our keyboard. So I'll just use this button and let's see the result. And you can see we have a response from the API, which is a JSON file. It looks to be the same one as we see in the previous example. And what we'll do next is we'll try to extract some fields from this JSON response. And what, as I mentioned, I really like to see an example of how my JSON is structured. So I'll use this as a reference. And as you can see in the example, so what we did here is we defined the URL. We also used some parameters. Since I want to extract a lot of information, I probably won't be able to extract all the data from all the seasons. So I specified some kind of date that I'll be searching for. So in this case, the 1st of January, and this is my start and end date. And I'll start with page 0, and I'll try to get 100 statistic entries from the API at once. And this is the same request get function that we used in here. I got the response. I kind of saved the response I got from the API. And in here, I started navigating my JSON. As you can see, the JSON has different keys. So this data or meta fields can be treated as keys. And in here, this is the way on how can we access those keys. So what I did here is I kind of specified that my statistics variable will be stored in the data key, and the metadata will be the metadata variable. And for each of these statistics, I decided that I'll be using ID, assist numbers, blocks, rebounds, the number of minutes that player played, points player recorded, and these ID, assist, block, rebound keys are the same as in here. So if I say that I need to see the assist of this statistic, number of assists for this player, then I would be kind of trying to retrieve this number. If I need minutes, then I'll be using this number. And I'm also extracting the player name and surname. So player information is stored into another key. And if I expand this one as well, I can see that we have player name, player surname, the position that player plays in, and the ID of the team. So yeah, I'm extracting some actual statistics, and later on, I'm loading that information to the database. So I created a SQL Server database, and the instructions on how to install it was also, part of the list of programs that could be installed before the session. I specified the server name, and my SQL Server name in this case is localhost. This is the default name when we are creating the database. So if you haven't changed anything during the installation, you'll have the same name as well. And I'm specifying a database for which I'll be inserting all this data that I extract in here. And yeah, maybe what we can do next is we can check how our final database could look like. So this is the part, this is kind of a script that data engineer could create for accessing the API. So in here, we access the API, we define what data do we want to access, we extract some statistics. In this case, we are also doing some data cleaning, like we are removing some quotation marks in players' names, and we are sending that data to our data warehouse. For navigating the data warehouse, I like to use Azure Data Studio. It was also one of the programs that I recommended to install. And during the installation, I created a new SQL Server that I'll be using. What we can do, let's say I'll delete all the databases that I have before. And let's say right now I have a empty installation of the server. So what I need to do is I need to create some databases. And this is another part of data engineers' work. Like we need to ensure that we have some databases where we'll be storing the data. So in here, I am creating a staging database and the final database for storing the data warehouse. So I can just click run, and here on the bottom we can see that we have the database is created successfully. Then I also need some tables as well, and in here I'm creating some tables, adding names for each of the columns, and these names are the same as the ones that we are extracting. So I'll go ahead and I'll create all these tables. And if I refresh my database view, we can see that now we have data warehouse and some staging data that we'll be using on later on. So now I have the tables for statistics. So this table will be used for storing the raw data from the API. And this kind of can be treated as raw data since we're not doing many transformations. We're simply selecting some fields that we want to query. And we'll send the data to this table, and later we'll figure out where do we want to go next. So in order to run this code, as I mentioned, we click this one. And what our code did is accessed the API, asked for statistics on this date, and loaded that data to our staging table. And now if I query my stats table, I can see that there is some information loaded. So we have ID for each of the rows. This is just a simple identifier. We have number of assists, blocks, rebounds. We have the date when the game was played. We have player, first name, last name, position, ID of the player, and the team ID. In this case, IDs are kind of identifiers. So if we have player ID 105, it means that in all our statistics, the specific player will have this ID, and the team that that player played for has this ID. So now I have my data loaded to the database, and the final step would be to transform this data and load it to the data warehouse. So now when creating the data warehouse, let's say a data analyst approached me and asked me to provide some data about the players and the games they played in, and maybe some statistics that they generated during the games. So then I know that I'll be building a data warehouse. I'll have a dimension for player, and I'll have a fact table for statistics. So dimensions and facts in the data warehouse represent different business units or activities. So in this case, we have a player dimension, and it means that all the information about our players will be stored in this table. And the fact player stat table will store all the statistics that those players generated. So I will not be storing player information in this table. I'll be only registering the actual games and their statistics that these players played in. And if I check how my player statistic table looks like, so for now it's empty since I did not load any data, since we loaded data only to the stats table. And I also provided some SQL queries for updating those dimensions and fact tables. I will not go, in detail what those queries does, but the main idea is to use the raw data that we loaded from our API and to transform it to two tables. So I'll extract in one table, I'll extract only player information, which is kind of on the right side. And for the for the player dimension and for the fact table, I will use only the actual statistics or the left part of this one. And of course, we are already able to do some analysis on even, on this raw table, but it would be better if we provide clean data for our business users to use. Yeah, and I see that there was a question, what code am I using for table creation? So to create tables in the database, we are using SQL code, which is kind of defining what, in this case, the database schema and the table. So my database is for staging data is staging database, and the table name is stats. So yeah, I simply specify that I'll need the stat ID column that will have integer type. I would have assist column that would have integer type, and so on. And I did this for both staging data and for player dimension and for player statistics fact table. And maybe also what distinguishes the data warehouse from the staging data is that in the data warehouse, I want to have as descriptive columns as possible. So instead of using abbreviation AST, I'll write the full name assists, since I want my data analyst or other data users to understand data, if possible, only by looking at the columns. Because yeah, this could be interpreted in many different ways. Maybe it's not really clear what PTS means. So instead of using PTS, I'll write the full name points. So in the end, yeah, the data would be more kind of more described in the tables. So I'll before I update my data in the warehouse, let's load one more date. So I'll change the date to the 2nd of January. And let's do the 3rd of January as well. And I understand that all of this could look a bit overwhelming, and of course, it takes time to write such, even simple, code blocks for using the APIs. I think I spent around an hour or something like that to, write the whole disk. So if at some point you'll start your career in data engineering, of course it will take time, but after some time, you'll see that it's not that complex or not that difficult. So yeah, I loaded a few more days. And what I'll do now is I'll run this SQL code to move the data from my staging environment, from my staging table to the actual data warehouse. And we can see that we have around 400 rows, I think, for stats, and 400 rows for players, and for the actual stats. So let's see how our player table looks like now. So this is the data that we loaded to our player dimension. And you can see that we have ID for each of the players, have name, surname, position, and the team they played for. And in the fact table for statistics, we have some actual stats that our players generated. So we have, instead of writing, the full name and surname of the player, we're using only ID in here. We have a date. We have number of points that was recorded, minutes played, rebounds, blocks, assists, and so on. And finally, what the data analyst would do is he would use this data from the warehouse to create some kind of a report. And I guess you had a session on data analytics before. So mainly in most of the companies, the data analysts use the data their data engineers provide. So as I mentioned, then our data engineers can focus on building the data pipelines. We're doing all of this that I showed in here, and then the data analysts could write some SQL code to analyze this data. So let's say I want to check the total number of points that was recorded over these dates. So I would write select sum of points from my statistics table. And we can see that during those 3 days, there were a total of 4,000 points recorded. And if I want to see how many points each player recorded, I would write group by. I want to group it by player, and I want to see, the player ID as well. And here we have all the player IDs and the number of points each of these players recorded. And now, using those player statistic and the player dimension tables, our colleagues could do some data analysis. Analysts could create some reports, or in our company we are educating like non-technical people as well. For example, customer support. We were giving a introduction for doing analytics to customer support. So we showed them how to create some simple reports, and we showed them where they can get the data. So it's not that difficult to make some basic, graphs, even by using Excel, when you have good data in the data warehouse. So yeah, that would be the short example. And maybe just to recap, let me go back to the slides. So what we did in here is, this is the slide on the data warehouse. In our case, we used only one data source, so that was Basketball Statistics API. We wrote a small Python job for extracting, doing minimal transformation and loading that to the data warehouse. And then we created some dimensions and fact tables on the data warehouse, and wrote a small SQL code for just seeing the total points for each player. So yeah, and of course the data warehouse is usually like a lot bigger. We have many more dimensions, many more fact tables. We are loading different kind of data sources. Maybe we also have many different data pipelines sending the data to data warehouse, and we have many reports and business users that are using the data from the data warehouse. Yeah, and I guess now we have at least a bit of understanding on what value the data engineering brings. So usually data-driven companies, as Infer is, we rely on huge volumes of data. So we need to have good data pipelines to process that data, to clean that data, and to help the whole business decision-making process. And in most companies, we have many different systems that are generating the data. So, for example, we could have one system that's responsible for billing and shipping, like let's say order shipping information. We can have another system that has all the history of orders. Then maybe we have another system that's responsible for tracking the customer support information, like number of tickets our customers created and so on. And let's say we want to create a report that analyzes the revenue we get, also including number of orders our customers created, and maybe number of tickets that the customer support received from these customers. Maybe we want to investigate if those customers who create more tickets, if they also create more orders and we get more revenue from them. So it would be difficult to create a report by connecting to all these, different systems at once. So in this case, the data engineering would help to create data pipelines that would get data from these 3 different systems, load them, transform them, and store them to data warehouse. So finally, we can use, the main or the centralized location for analyzing the data. Also, data analysis can be very challenging because the data sources can be very different. So, for example, one data source could be, as I mentioned before, the API, which returns JSON. Another data source could be a simple Excel file, and maybe the final data source can be a database. So, by building data pipelines, we are connecting those pipelines to all these different data sources, and then finally storing our data in unified data format, which in the exercise I showed before, the data warehouse is located in the SQL server. So it means that we can write SQL code to analyze this different data. And the data engineering, is designed to improve and support the whole process from the extracting the data, from investigating where can we get the data, to doing some transformations, creating monitoring, documenting the data that we get, and educating our end users so they would know where they could find the data. And then we are if we allow our business users or our data analysts to focus on analytics or getting some insights from the data we have, then we are kind of making the whole company more efficient. Our data engineers can focus on providing the data, analysts can focus on analyzing the data, and the whole, data-driven mindset works better for companies. And yeah, I think that that is all. That's all for me. And I see also a question on what data visualization tools Inphia uses. So for internal analytics, we have Power BI. So we are creating Power BI reports from our data warehouse usually, but also we have some custom products that we sell to our customers. So our developers create some web applications where they are visualizing the data that our customers buy from us. And no, we don't really use Tableau or Looker. Just historically, Inphia is kind of used to Microsoft technologies, and since Power BI integrates really well with all different Microsoft applications, we're using mainly Power BI for our data visualization needs. And I see another question about Excel and macros data engineering. Yeah, so when I started doing data analytics in one of the banks in Lithuania, we didn't have, access to many tools. We used Excel only. And I would say that, yes, it is possible to create data pipelines by using Excel and the macros in Excel. But I guess it works for small data pipelines and, for small amounts of data. By saying small, I would say, I don't know, like Excel limitation, I think it's 1 million rows per file. So yeah, probably like tens of thousands of data would be the limit for the data pipelines. But if you don't have other tools available, you can still, do some pipelines using Excel and macros only. But if your data would, increase in size, like you would get more rows or you would get more columns, you would start kind of start getting some performance issues, like your files could get too large for Excel to process. Your pipelines would start getting slow, and in that case, even simple Python applications for getting the data from Excel, transforming it, would be better to write those data pipelines. But yeah, I would say that Excel is not really a necessary tool in general, but personally, I really like it for analyzing some small samples of data because, yeah, of course, I'm biased in this case because I really worked with Excel a lot. So even when writing some data pipelines, I would copy that data to Excel file and do some, analysis in there. But I wouldn't call that a necessary tool, but it's very nice to have tool. Another question is whether we're using Jupyter notebooks. So in our team, we are not using Jupyter notebooks because usually we are we really like the Visual Studio Code, that I showed before. It has a lot of plugins and extensions, and it's really easy to work with Python on Visual Studio Code. But I use Jupyter notebooks for my home exercises. Like I have some Jupyter notebooks where I'm analyzing my utility bills, amount of electricity that we use at home and so on. So for that case, yeah, I'm using Jupyter notebooks. And we are not using R for data analysis since we cover all our analytic needs using Python. Since historically, I think R was more robust, it had more libraries for analyzing the data, but like 10 years ago, there were a lot of new libraries created for Python based on what was available on R, and nowadays you can do kind of all the same that you can do with R as well. And since Python is more flexible and has more applications, we're using in our company Python only. The next question, so what is the best place to start if you want to be a data engineer? I would say that there are two main paths to becoming a data engineer. Usually, yeah, so two paths. Okay, so the first one is we are seeing data analysts starting to work as data analyst, maybe, learning some data visualization tools, let's say Power BI, starting to write some database queries, and later on, those data analysts start to get better at writing database queries. And they naturally, if they see if they want to do the data engineering, in their companies, they're naturally starting to progress from data analytics to data engineering. And I'm hiring, some data engineers as well. So we have many candidates who become data engineers from data analysts. And another path is we are also seeing some software developers who start, as writing software only in using, let's say, Python, C# or Java or some other programming language, and they kind of really love working with data, and they transition from software engineers to data engineers. Unfortunately, I haven't seen many cases where we see people becoming data engineers, like just from after finishing university or by kind of changing their career path. I guess it's more common to start with data analytics and then becoming a data engineer, since for data engineering you need more like programming skills and so on. For courses for data engineers, to be honest, I haven't checked, many courses on data engineering, but if you would write me via LinkedIn, I can find some courses, or maybe if Elżbieta gives me a list of attendees, I can, check for some courses afterwards and just send email for everyone. Maybe that will be useful for all. The next question is whether I'm working with non-relational databases. So in our team, we don't really work with non-relational databases, since all our data needs are covered by using relational databases only. Since we are doing the data warehouse and we want our data to be kind of clean, standardized, and as easy to understand as possible, so we're using only relational databases. Maybe a short comment for those that are not familiar with this term. So relational databases can be imagined as a table, like you have fixed amount of columns and you have data coming in different rows. And non-relational databases is some databases that allow to work with unstructured data. And the JSON example that I showed before is an example of non-structured data, where the data can have like different layers, different columns, like different fields, and so on. But it's really a good skill. I mean, this is working with relational databases is only like a specific thing in our company, but in general, in the whole data engineering industry, it's really a good skill to know how to work with non-relational databases as well, because there could be some areas where it doesn't make sense to use relational databases, and it would be a lot easier to use non-relational database. Another question is what Python libraries are most used. So in our team, we are using mainly some libraries that allow us to connect to the database. And as you'll see in the code example that was attached to this lecture, I think we're using PODBC, which kind of allows you to send the data from Python to database. Sometimes we're using Pandas as well. Pandas is a library that allows you to transform the data, like change the column names, maybe do some data grouping, data filtering, and so on. To access APIs, we use requests library. It's also used in this exercise as well. If you need to work with Excel files, maybe you need to get the data from Excel files or use Python to store data to Excel files, then I think there are a few libraries that can be used for that, but yeah, I don't remember the specific names, but mainly libraries for accessing databases and libraries for transforming the data and querying the APIs. And the final question I see is, does Infia has partnerships with programming schools in Lithuania? To be honest, I think we not have like partnerships, as such with those programming schools. but we are definitely hiring people from programming schools. I used to teach a few years ago. I used to teach data analytics in one of the coding schools, and I know that there are people coming in who are really motivated on changing their career paths and learning new technologies. So we are, hiring people from data schools, programming schools as well. And last year we had the data analyst joining our company, who also finished one of the data schools in Lithuania as well. All right. Hopefully, I answered all of the questions, and I'll try to look for some courses on data engineering. And yeah, as I mentioned before, if you have any questions, you can find me on LinkedIn. Yeah, so I guess that would be all. Thank you all, of course, for listening.